Hey everyone, welcome to our vlog. And this time, we will be talking about ecology. In today's vlog, we will be talking about the different species and the species diversity. So what is a species? A species is a set of individuals having the same distinct characteristics and able to mate and produce fertile offspring. While species diversity is the number of life forms present in a biological community, and that is about 8.7 million in organisms in our universe. So when we talk about species diversity, there are three things that keep in mind. First, we have species richness, then species abundance, and lastly, we have species evenness. So to differentiate the three, when we talk about species richness, it's the number of different kinds of species in a particular area. So we're talking about organisms, all organisms that are present in a particular. While species abundance is the number of individuals per species, and relative abundance refers to evenness distribution among species in a community. Lastly, we have species evenness, which is the abundance of individual members in a particular species. So the question is, how do we measure species diversity? Sir Wentz, you're up.
Hi, so thank you, Sir Jules. Okay, so to measure the species diversity of an area is by knowing its diversity index. So what is this diversity index? A diversity index is a quantitative measure that represents how many different types of species there are in a community, and that can take into account to the phylogenetic relations among the individuals that are distributed among those types, such as richness, divergence, or evenness in a statistical representations of biodiversity. Okay, so there are several types of methodologies that can be used in order to measure or calculate diversity index. One of these methodologies is what we call the Shannon Diversity Index. Okay, so this video will be focusing about the Shannon Diversity Index, field study data gathering, steps to calculate diversity index using Microsoft Excel, and the importance of knowing the diversity index of an area in the ecosystem. So we hope that this video will serve as a guide in your respective area of specialization and to help you in your current and in your future research. Thank you.
The Shannon-Weiner Index of Diversity, or also known as Information Index. It is derived from the theories developed by Claude A. Shannon and Norbert Weiner and published in 1949 by Shannon and Warren Weaver, that is used by ecologists when a system contains too many individuals for each to be identified and examined. A small sample is used. The index is the ratio of the number of species to their importance values, like biomass or productivity, within a trophic level or community. The Shannon-Weiner Index is a statistical representation of biodiversity by taking into account the species richness, the species evenness, and the species abundance. Species richness is the total number of species. Species evenness is the distribution of each species within the community. Species abundance is the number of individuals belong to each species.
Everyone, I am here today to do a field study on species diversity.
So we are now going to the forest. We will see what kind of species we are going to see in this area.
So ngayon nakikita natin ang iba't ibang klase ng mga puno at halaman dito sa ating kinalalagyan ngayon. We have seen the different kinds of diversity here in this area. How do we compute the index of diversity? Ma'am Sisi, it's your turn!
How to compute diversity index using Excel. So let us identify first the equation to use in computing diversity index. So we have D is equal to capital letter N multiplied by capital letter N minus 1 over summation of small letter n multiplied by small letter n minus 1, where D is the species diversity index, capital letter N is the total number of organisms of all species, small letter n is the total number of organisms of each species, then the summation is the sum of. So here are the steps to be followed in computing diversity index. Step 1, calculate the big letter N. Step 2, calculate big letter N multiplied by big letter N minus 1. Then step 3, calculate small letter n multiplied by small letter n minus 1. Then step 4, calculate the summation of small letter n multiplied by small letter n minus 1. Then the last one, step 5, divide big letter n multiplied by big letter n minus 1 by summation of small letter n multiplied by small letter n minus 1. So let's have this example. So in our table, we have here a species, then the number n and the n multiplied by n minus 1. So let's say we have 5 different species. We have A, B, C, D, and E. And the number of organisms in each species is given in column B, wherein A is equal to 10, B is equal to 18, C is equal to 16, D is equal to 2, and E is equal to 8. Then the total number of this species is equal to the big letter N, which is 54. Then for small letter n multiplied by n minus 1, so get the number of species in each organisms. Then we have for A, 10 times 9 is equal to 90. For B, we have 18 times 17 is equal to 306, and so on in letter E. Okay, so the summation of small letter n multiplied by n minus 1 is equal to 694. Okay, so for step 1, we have to calculate the big letter n. That's the total of all the organisms. So we have 54. For step 2, so big letter n multiplied by big letter n minus 1. So we have 54 multiplied by 54 minus 1. So 54 times 53 is equal to 2,862. Then for step 3, we have small letter n multiplied by n minus 1. Wherein that's in column 3 or column C. There, we have the individual number of species. Then step 4, summation. So we will get the sum of all n multiplied by n minus 1, that is equal to 694. And the last step, we have to divide big letter n multiplied by n minus 1 to the summation of small letter n multiplied by n minus 1. So we have 2,862 divided by 694. So our answer is 4.12. And take note, we have to get only the 3 significant figures. So our diversity index is equal to 4.12. So take note that the higher the value of D, the higher the diversity. Now, let us analyze how healthy, how even, how rich the area is in terms of biodiversity using our data. Since there are 5 species in our data, our species richness is equal to 5. So we can say that there is a high richness. Take note, the higher the number, the higher the species richness. For the species evenness, we can say that there is a low evenness in our data because one species or species B dominated the area and there is no even amount among the species in the area. For the species abundance, we will just get the total number of organisms in the area. It does not matter what species they are. So if we add all the organisms, then our species abundance is equal to 54.
Thank you, Ma'am Cici, for teaching us how to compute the diversity index using the Excel. Now, let us apply this knowledge. We have a comparison between communities. Community 1 with diversity index of 4.12 and community 2 with diversity index of 1.2. So now, how do we interpret this data? Let us always remember that the higher the value of D, the higher the diversity. Typically, the value of the diversity index increases when the number of types of species increases and the evenness increases. In short, the species richness and species evenness is directly proportional to the diversity index. Let's go back to our example. So we can say that community 1 is more diverse than the community 2. Why? Because community 1 has higher D value than community 2. We can also say that communities with a large number of species that are evenly distributed, like community 1, are the most diverse, and communities with few species that are dominated by one species, like community 2, are the least diverse. What is the importance of knowing the diversity index or the index of an area? First of all, a diversity index is a mathematical measure of a species diversity in a community. Diversity indices provide important information about rarity and commonness of species in a community. The ability to quantify diversity in this way is an important tool for biologists trying to understand community structure. This biodiversity index is commonly used because it is a quick way to differentiate between different locations, different ecosystems, or a population of organisms. It is a calculation of a total number of species in a particular place or an area.
Many people are making the world a better place to live. But humanity as a whole is making it difficult for other living creatures to survive. The effects of human activities on biodiversity have increased so greatly that the rate of species extinction is rising from hundreds to thousands of times the background level. One by one, species can disappear. Only then will we shed a tear. So always remember, biodiversity is the food we eat, the water we drink, and the air that we breathe. More than that, biodiversity is a part of us, as we humans are part of nature. God bless.